Hello everyone. We're going to talk today about lesson 8.3. This is the first video of two. The first one for today, the next one will be for tomorrow. So one of the biggest things in this lesson will be something called completing the square, which I will be describing here shortly. But again, just want to remind you about something I mentioned yesterday, the importance of knowing the three distinct forms of a quadratic equation. Notice I did not have any of the equals y here. I just didn't put that on there for now. But this standard form, vertex form, factored form. And like I said, we need to work on being able to go from any one to all the other ones. So yesterday, we worked on taking vertex form and converting it to standard form. All right. And today we're going to go the opposite way. I'm going to give you something in standard form and we got to put it into vertex form. So that's going to provide some of the main work that we do, the basis for that work. So let's get started. One of the first things that I want to point out before I show you how to convert from this form to this form is if you had an equation like y equals x squared minus 10x plus 100. Clearly a quadratic equation in standard form. Now, if you were to ask or try and say, what is the vertex of this parabola, right? Because it's a quadratic equation, all quadratic equations graphed are parabolas. We know because A is positive that it's going to be a parabola going up, so we would be we'd be looking for a minimum here. Now, as we get into word problems, knowing and being able to find that vertex is going to be pretty important. That is a very interesting point in a lot of scenarios. And so the first thing I'm going to show you is a method that can just find that vertex when you're given standard form. And that is just a formula, which is negative b over 2a, comma, f of negative b over 2a, right? So once we find the x, you just plug it into the f function to find the y. Hopefully that makes sense. So if we were to apply that here, and we'll be able to explain why this is the formula for the vertex once we learn how to complete the square. But for now, I'm just telling you what it is, and you can use it. All right, so in this case, negative b, which is negative 10, over 2 times a, which is 1. That's going to give us our x value. So negative 10 is positive 10, over 2 times 1 is 2, x is 5. Okay. Now, for the y, we have to plug that into the f function, which we're going to say this, maybe I should have called this f of x first. Right? It's just another way of, or another notation. F of 5. So we're going to substitute 5 in. And we get 25 minus 50 plus 100, which simplifies to 75. So the vertex of this particular parabola is 575, right? Go ahead and check that. Put that into Desmos, click on that lowest point, you get 575 for your vertex, okay? So that's one method. Notice it didn't require us putting it in any different form. It was just using a little formula that I had given you, that I had provided for you. Now I want to show you, we're going to take that same equation, and this time we're going to find the vertex by putting it into vertex form. So that all we have to do is look there, and we'll know our vertex. So here's how this works. This is called completing the square. You begin by putting a gap between your linear term and the constant. There are two things that are going to go in there. The first one's always going to be a plus. The second one's always going to be a minus. So plus something, minus something. And what we put in those blanks is going to be the same number, and because you're adding and then turning around and subtracting that number, you're not actually changing the value of that equation, right? It'd be like saying, hey, I have 10, but then I'm going to add 7 and subtract 7. What am I left with? Well, you're still left with 10, right? You haven't changed the value by adding 7 and then subtracting 7. Okay, so we're not changing the value here. So we got to figure out what goes in those blanks in order to create the situation of having a binomial squared. Well, how we do that is we kind of think backwards, and I'm going to save you from all the thinking at this point, which goes against everything I believe in as a teacher, but I'm just going to tell you. You take the b term here, which is -10, and you take half of that, -5 obviously, and you square it, 25. Notice, because we're always going to square it, this value here is always going to be positive. It doesn't matter if this was a negative or positive. You take half of that coefficient, which is 5, and you square it and put that number there. Like we said before, that number goes in both spots. Okay? Now, this first part, these first 3 terms now, are going to be able to be simplified just as these last 2 terms are as well. So if we simplify these first 3 terms, this turns into x minus 5 quantity squared. And go ahead and check that. If you take x minus 5 times x minus 5 and do your foiling, you will get back to this. So we're rewriting this in this form. We forced it to be a perfect square here, just like this. And now the rest of this over here just goes on the outside. -25 plus 100 is 75. So there is our vertex form. Okay. And notice you can quickly find the vertex by saying, all right, well, the h, remember, it's kind of the opposite of this. So this is -5. It's going to be 5, and then 75, the same there. Okay, and that's what we got the first time with that formula. But there's a way to find the vertex by putting it in vertex form. That's one of the benefits of having vertex form, is you know the vertex right away. Okay, let me quick show you 2 other examples of completing the square. The first one is y equals x squared plus 6x minus 11. So in this one, here's the process again. Remember, we leave that blank space in between. We're going to go plus a blank, minus a blank. All right? So what's going to go in those blanks? Well, we go to our b term here, our coefficient of the linear term. So the 6, do half of 6, which is 3. Square it, you get 9. New markers. And so 9 goes in both spots. This right here, we can rewrite. It's a perfect square binomial. X plus 3. I knew it had to be plus 3 because that's half of the positive 6. And again, notice, if you were to multiply this out, and here's what I mean by multiplying it out. I hope you guys understand what I mean. This is what x plus 3 squared actually means. And then you do your foiling. There's x squared. There's 3x. There's another 3x. And there's your 9. These two combine to give you 6x. X squared plus 6x plus 9. There it is. Checked it. It works. Okay. So you got that, and then you simplify this part over here. -9, -11, -20. So if we were to ask what our vertex was, it would be the opposite of that, which is -3. And then this value here has k value, -20. Done. One more. I'm going to make it a little harder. Show you one of the more advanced ones. Let you practice a little bit here, and then we'll obviously go through more tomorrow. Y equals 4x squared minus 12x plus 3. Okay, so we're going to complete the square on this one. notice, first of all, our a value is no longer 1. So we have to work with that. And here's what we do. Go ahead and still start out with your space, but don't do your blanks yet. You can only start that once your a is 1. All right. So we have to pull out that 4. We have to factor out that 4. I want to make sure I'm doing this right. But we're not going to factor out the 4 from the last number there. We're just going to factor it out from the first 2. So we're left with x squared minus 3x. Okay. At this point, we are going to do our plus our blank and minus our blank. Now I'm just thinking here a second. I think it's going to be easier for us to only do one blank in here. Okay. We're going to do plus our blank in there. Okay. And then we're going to do minus our blank out here. All right. Now, this is going to have some ramifications that we got to be careful with, but I trust we can handle it. All right. So what number should go there? Hopefully by now you've got the idea down. Half of this term here, so half of -3, -1.5 squared. Uh-oh, we got a square decimal. That's okay. You can write it as a fraction or a decimal. It doesn't matter. So I'm gonna do this in my head. So half of that is -3. Oh, come on. So -3 over 2. And then I have to square that. So I have 9 over 4, which is 2.25. Okay. 9 over 4. Now, here's the thing. We can't put 9 over 4 in this blank here. Okay, you go, why not? Well, this 9 over 4 is inside of a set of parentheses with a 4 out in front. So by putting it there, that value, actually, we have to think of the value if we were to distribute this 4 through. So that value of putting that in there was actually 4 times 9 over 4, which is actually a value of 9. So it actually has to be 9 that goes out there. Okay, so if you're ever having to factor out that, before you put in that second blank, you have to multiply this this number out in front by whatever you filled in with the first blank. All right, now this is a perfect square. It's -3 over 2, or -1.5 squared. And then we combine these out here and get -6. And so our final answer, if we were to identify the vertex, is at 3 over 2, comma, -6. And again, feel free to check these when you do these. You have Desmos available to you. So make sure that you're getting accurate answers there. I'll be doing some word problems on the next one tomorrow, but right now you just need to practice completing the square. Take care, everyone.